So if you look at the family tree, you see things are descended from the things that came before it, from their ancestors, just like your own family tree. And that's called vertical evolution, because you think of your genes being handed down towards your descendants. But there's horizontal evolution, or horizontal gene transfer, where it is, well, I would say take my genes and transfer them to you. Let's suppose I could suddenly do that, and you could then take my genes and you would then be able to do what I could do. So if I wanted to teach you, say, theoretical physics, and theoretical physics was something that could be transmitted by genes, I could just sort of pop out a little bit of DNA, give it to you, you could absorb it, and bang, suddenly you'd be able to do theoretical physics. Okay, now that's science fiction. That doesn't happen, but it does happen in the world of bacteria. So microbes can do this, and they, in fact, they do learn new tricks by doing this, and one of the tricks that they learnt was how to evolve resistance to antibiotics. So the reason that all our antibiotics are starting to fail now is because of this ability to transfer genes horizontally. And that's a very fast mode of evolution. Evolution can be very rapid when you transfer genes horizontally. It's a community effect, it's a collective effect. It depends on the size of the community. And so therefore, excuse me, so therefore it's, as the community grows, it gets faster. And indeed that's what we think happened to the genetic code, that it evolved by horizontal transfer, and that caused it to evolve rapidly. And also, in fact, what we showed was that it caused the genetic code to have this optimal characteristic, to be the best possible code at minimizing errors, and also to become a unique genetic code across all organisms. All of those things come out of our theory. Now, how do we know that? Well, the equations that describe this evolutionary process are very complicated. So what we did was we made a simulation of life in a computer. So we simulated organisms that can live inside a computer, and they have proteins, and they create those proteins by translating a genome. They have errors, they can evolve, they compete for resources, they have offspring, all of the things that mimic what real organisms do. And they can also, if we wanted to, we could turn on the feature of being able to transfer genes horizontally. And then we simulated this system.